Hello, hello, and welcome to this video. In the last video, we did some querying, and before that, we did pgdog and citus, and before that, we had done date time data type. So this video is of the theory side of the PostgreSQL. So we will read through Boolean type, and there will be enumerated types also. So we'll cover these two in this video. So we'll cover section 8.6 and 8.7 and possibly 8.8 also. Okay. So 4 or 5 pages of read through we will do. So let's start with Boolean types. So PostgreSQL provides the standard SQL type Boolean. The Boolean type can have several states, true, false, and third state unknown, which is represented by the SQL null value. So the name of data type is Boolean, storage size is 1 byte, and it can represent either true or false or unknown. So Boolean constants can be represented in SQL queries by the SQL keywords true, false, and null. The data type input function for type Boolean accepts the string representation for the true state, true, yes, on, or 1. And these representations for the false state are false, no, off, and 0. Unique prefixes of these strings are also accepted. For example, T or N, leading or trailing white spaces is ignored and case does not matter. The data type output function for type Boolean always emits either T or F as shown in example 8.2. So here a test1 table is created. A is of type Boolean, B is of type text. So A is set to true and false in two different columns, and when you select, it shows T and F. And again, it selects rows where A, that implies A is true. The keywords true and false are the preferred SQL compliant method for writing Boolean constants in SQL queries. But you can also use the string representation by following the generic string literal constant syntax described in section 4.1.2.7. We have not seen this yet, but we will see at some point of time. For example, double quotes yes, colon, colon, Boolean. Note that the parser automatically understands that true and false are of type Boolean, but this is not so for null because that can have any type. So in some context, you might have to cast null to Boolean explicitly. For example, null colon colon Boolean. Conversely, the cast can be omitted from a string literal Boolean value in context where the parser can deduce that the literal must be of type Boolean. Now we look at enumerated types. Enumerated types are data types that comprise a static ordered set of values. They are equivalent to the enum types supported in a number of programming languages. An example of an enum type might be the days of the week or a set of status values for a piece of data. So how do you declare this? So these are created by using create type command. For example, create type mood as enum, sad, okay, happy. So this will create a type mood which can have one of the three values. So how do you create such a table? You first create the type, and then you say create table person. First column is name, which is of type next. The second column is current underscore mood, which is of type mood. Insert into person values mo happy. Select star from person where current mod is equal to happy will give you the name and current mood since there was only one column, one row. So it will return that one row with current mood happy. Now we look at ordering. The ordering of the values in an enum type is the order in which the values were listed when the type was created. All standard comparison operators and related aggregation functions are supported for enum. For example, we put in two values, sad and okay, and select star from person where current mood greater than sad. So happy and okay are returned. Now if you see the declaration, sad is the first value here. So okay and happy will have greater value than sad. Similarly, If you order by mood, then okay will come first and happy will come second. And if you select min, then min would be sad. So it will become Larry, because here we are selecting name from person, where current mode is select min current mode from person. Now we look at the type safety of enumerated data types. Each enumerated data type is separate and cannot be compared with other enumerated types. See this example. So in this case, happiness enum is created where three values are stored: happy, very happy, and ecstatic. In the table holidays, we have happiness column of type happiness. Now insert into holidays num weeks, comma happiness, which is 4 and happy, then 6 and very happy, 8 and ecstatic, 2 and sad. But when you will try to insert sad into happiness, it will throw an error, because sad is the mood, not happiness. So it will complain that operator does not exist, mode is equal to happiness. Okay, so if we want to do that, we need to write a custom operator or add explicit cast. So what we can do is person.currentMood text is equal to holiday.happiness : text. If you do this, then you can select person.name holiday.numweeks from person holidays, where so if here we are comparing current mood with holidays happiness. So if you look at this, then this is happy. Okay, and over here we had happy. Mo was happy. So the textual value of both the happies are same. So you can use the text-wise comparison and Mo will be returned. But you see, in this case, the num weeks was 4. So the final output is 4 here. Now, implementation details. Enum levels are case sensitive, so happy is not the same as capital happy. White spaces in the labels is significant too. Although enum types are primarily intended for static sets of values, there is support for adding new values to an existing enum type and for renaming values. See alter table. Existing values cannot be removed from an enum type, nor can the sort ordering of such values be changed, short of dropping and recreating the enum type. An enum value occupies 4 bytes on disk. The length of an enum's value's textual label is limited by the name data length settings compiled into PostgreSQL. In standard builds, this means at most 63 bytes. The translations from internal enum values to textual labels are kept in the system catalog pg_enum. Querying this catalog directly can be useful. Now we move on to geometric types. There are several geometric types which Postgres gives us for two-dimensional plane objects. So those are point, line segment, box, path, and then we have polygon and circle. The storage size are also described here, and the description as is evident from the name. And the representation of these are also given here. So a point is simply xy, so that's how you insert. We will see SQL queries of geometric data types later on. We are still far away from discussing geometric types when we are writing queries. First, we will complete the general non-spatial queries, and then we will move on to spatial queries. So this is simple xy line. Lines are represented by the linear equation x plus by plus c is equal to 0, where a and b are not both 0. Values of the line are input and output in the following form. So you can give ABC, or you can use any of these forms, x1, y1 and x2, y2, that is 2 points you have to supply. For line segments also you have to specify 2 points. Okay, those are the end points of the line segment. Boxes can be represented by a pair of points that are opposite corners of the box. Values of type box are specified using any of the following syntaxes. So it is same as line segment or this part of a point. That's how you represent boxes. Boxes are output using the second syntax. Any two opposing corners can be supplied on input, but the values will be reordered as needed to store the upper right and lower left corners in that order. So first it will store upper right corner and then lower left corner. Paths are represented by a list of connected points. Paths can be open, where the first and last point in the list are considered not connected, or closed, where the first and last points are considered connected. Values of type path are specified using following syntaxes. So you can give two or more points which will form a path, where the points are the endpoints of the line segment comprising the path. Square brackets indicate an open path, while parentheses indicate a closed path. When the outermost parentheses are omitted as the third line through fifth syntaxes, a closed path is assumed. So by default, if you don't give parentheses or bracket, then it will be a closed path. Otherwise, if you have brackets, then it will be an open path. That essentially what it means is, if you want an open path, you have to give brackets. Otherwise, it will default to a closed path. Polygons are represented by a list of points, the vertices of the polygon. Polygons are very similar to closed paths. The essential semantic difference is that polygon is considered to include the area within it, while a path is not. An important implementation difference between polygons and paths is that stored representation of a polygon includes its smallest bounding box. This speeds up certain search operations, although computing the bounding box adds overhead while constructing new polygons. Values of type polygons are specified using one of the polygon syntaxes, where the points are the endpoints of the line segments comprising the boundary of the polygon. Polygons are output using the first syntax. That is, this one will be the output. Circles are represented by a center point and radius. Values of type circle are specified using any of the following syntaxes. So supply the center xy and the radius r, and circles are output using the first syntax. And next is network address types, which we will discuss in next video. So what I will do is that in the next video, I will show you how you can do querying using these geometric types. So on the 5th day, when it is the next PostgreSQL video for which we have to do the query part, I will show how you can insert these values and how you can get them from the tables as well. That is, insertion and selection I will show, and how you can query as well. There are certain queries which are kind of unique to this kind of disk type. So with this, I'll end this video, and I hope that you are finding this series of videos useful and informative. And if you are not subscribed to the channel, then please subscribe and like the video. If you have questions or comments, or if you find any error in the video, then make sure that you use comment box to register those, and I will do my best to reply to each of your comments. Thanks a lot for watching. Happy programming.